Hello! Something a bit different today, and to explain this I should say that even when you've got a relatively small YouTube channel like myself, you do get kind of a lot of email from people asking if you want to check stuff out. And it's mostly the fact they pretend they've watched your video and they're a fan and they want you to review something, and then you find out it's like for a light bulb. Smart light bulbs, I've had loads of requests. All sorts of bits of things to fit in your car and hold phones, they come up all the time. And it's like, really? And the other day someone sort of really personalised a mail and said they liked the channel, and they called me Curry. It's like, oh, they've shortened my name, they must have seen it. And it was for a shower head. What's going on? But occasionally something comes up and I think, that's interesting, I like that, even though it doesn't quite fit into the channel. What am I talking about? I got an email from someone on Elegoo who produces these things, asked me if I'd like to take a look at them. And I looked at it and I thought, you know, I really would. Why? Because A, it's a fun toy to build, B, it's Arduino based. And something I am quite passionate about is children and learning to program computers, not just use them. In the UK, up until a few years ago, the computer instruction in schools was pretty poor. They basically did things on word processors and Excel and called that IT. It's since changed in the last couple of years, so there's proper actual programming. I mean, it doesn't go too far. They start off in Scratch when they're little, they move up to Python. They do these little things with these little boards called microbits, which are used in school in the UK. Kind of a very basic input-output thing. Think of it like an Arduino, but it supports much more basic programming. So I was interested to see if this, A, is fun to build as me a grown-up, B, if I thought it was useful to build for a kid, and if they could expand it and learn about the programming aspects of the Arduino board that's using this. So yeah, I'll get it out of the box quickly and show you what's inside, but we're going to have to go to close-up for most of it, because opening up, you basically get another series of boxes. You get this manual, the assembly tutorial, which is pretty, I've just had a quick scan through and it looks pretty good about how bits go together. And then you get these 4 boxes. This is says it's the acrylic chassis. Doesn't say what's in it. A box, another box, and another box full, chock-a-block of loads of bits inside. So I thought, let's go to close-up, let's get them all out, and let's see how easy or hard it is to put together. Let's see if there's anything missing, and let's see if the entire thing's expandable. If you're like a young teenager who's really interested in this, could they go on and do more with it? Let's check it out. Okay, so let's go through this in a little bit more detail to see what's actually in those boxes. And what I'm going to do is take everything out to start with, and then we'll have a look in turn about what's actually there. So this bit is labelled as the acrylic chassis, so let's take a look at this. Labelled A and A, I guess that's which way up. See, it actually says in the instructions we'll be needing to take this sort of sticky back off before we start going. Let's move these out of the way for now. It actually says what should be on here. Uno L298N, Bluetooth module, I expansion modules, yada yada yada. Let's have a look. Yep, that looks like a ultrasonic sensory thing. That is, well, I think that's, is it the Bluetooth? Can't tell. That is something. Hope I'm not getting too technical for you guys here. This is a shield for the Uno, so stuff gets plugged in a little bit easier. Then we've got, not entirely sure what that is, let's say the L298N, some sort of board for doing something. And that's the main Uno, which is obviously a copy of the original Arduino one, but that's Elegoo's one. All the pins should be the same and stuff. That's cool. I'm just going to chuck this vaguely back in a box, so when I come to follow the instructions, I think it says things like, it's in this box. In here, more sort of the general bits to put on, plates and screws, insulation tapes. Let's have a quick look, see. Ah, it's nice. Things are actually labelled. I appreciate labels, so exactly how many we should have in and what there is. It says it's for the motor. PVC tape, that's I think for putting the line stuff down. Actually says for acrylic base plate. So I think that's really useful to say what it's for, and these have numbers on them as well, so hopefully these are gonna correspond to the actual instructions as well. Plenty of different things. More acrylic peely things. Plenty of it. And here's a little servo that's just mounted on this bit, ready for installation. Some servo arms, connectors that go in that hat for the board. This looks like the battery compartment. Ah, and that's good. I was going to say, do we need any tools for doing this? There's a little hex driver, Phillips screwdriver, and a smaller Phillips screwdriver. Okay, that's in that one. Then in the bigger box, tyres, DC motor, remote control, USB cables. Let's have a look. Well, there's some USB cables. Those are some motors, 4 off. A little remote control. And as advertised, there are some tyres. Awesome. Well, that's what's in there. So what I'm going to do is literally pick this up and start working through it. So I'm not going to sort of, time-lapse build or anything. What I'll do is I'll just take a look at each of the steps and then build what there is, and then I'll come back and comment on it and show you it as it comes. So I'll get on with this now. I'm back. I haven't built anything yet. Yes, as hoped, the instructions are pretty good. They basically say, here is what you need, and they give them numbers, and it says take 1, 2, 3 from bag with label for motor. We go and find the bag, it says label for motor. Brilliant, and the motors are pretty obvious. They look like that, just like the picture. Okay, that's the plate on my motor, or I should say motors, which leads me to a little nitpick. On this page it talks very much about a single motor. It doesn't say do it for all the motors, which is sort of inferred in the next page where we're going to install onto the chassis. But it's kind of nice to have that kind of explicitly told if you're sort of new to this and you're like, oh, where did the other ones come from? The other thing is I might mention is, although they give the tools to screw these in, something like a little spanner or a little pair of pliers would have been good, just so you can hold onto a nut to get it tight. I'm not sort of going super tight, but tighter than trying to hold it with your fingers. Anyway, let's get these things mounted on the chassis. Fairly straightforward, but really worth paying attention to the orientation, as I managed to mount a motor wrong at least twice on the way there. Anyway, next up, we are getting out the L298N module and mounting that here, and again it has its own little bag of things to use for it, so that's good. I'm guessing, as I don't recognise the L298, it's some sort of motor driver by the looks of it. So, although the bags aren't labelled, it's fairly easy to tell what's what from the picture, and the boards are actually labelled, so there's no sort of mistaking them. Okay, that's put together. Some nice close-ups there that does show the shims go underneath and which way the motors get plugged in, although they only plug in one way round, which is pretty nice. Okay, next up, we are fitting the line tracing module that looks like it goes underneath the main board, so let's crack on with that. Okay, so there's the line reader, which actually doesn't have a label on it, but it's fairly obvious what it is. Could have done with just a little bit of more illustration just to show how the orientation was done. And perhaps pointing out that you had to make sure this was the front way. Well, this is obviously the front, but it should be labelled that that's the back, which it kind of touched on that last time, but not quite enough. Anyway, it'd be pretty obvious if you'd got it the wrong way around fairly quickly. That's that bit done. Next step, looks like we're moving away from the bottom plate going to the top plate and putting on the Arduino and the hat and the Bluetooth module. Starts with mounting the Arduino by the looks of it, and then the hat. Let's get on with it. Okay, so that is the Uno mounted, the hat on top, and the Bluetooth module mounted in. Again, just slightly more explicit on the instructions would have been useful, just to say like about how you sort of press down and make sure that's in there. Again, the Bluetooth's not labelled, but it's fairly obvious, and all the stuff on the hat is labelled quite nicely, so that's pretty cool. Anyway, that's in place. Next up, we're going to be mounting the battery box, which actually got a lithium battery inside, so it's a little rechargeable thing, which is quite cool. Anyway, let's get it mounted. Okay, so that's the battery box installed. Quite nice that the instructions both went into making sure the wires are right, which way round the logo went, and also talked about what was on the box itself. So it's got the on-off, it's got a status indicator here, and that goes hand in hand with this little USB charge port, so it sort of goes to green when it's fully charged. Next up, we'll be working on the ultrasonic module, which is going to mount on the servo, and then, as you can probably see, there's a servo hole here where it's going to eventually go. Okay, we have this guy mounted. Certainly the fiddliest of the lot, because it's using little M1.6 screws and nuts here and M2s here, and my fingers are very big and it's kind of hard to get in there, so maybe this is where being a small child actually has an advantage. Anyway, that's that one done. Next up, the case of mounting that on the chassis itself and plugging it in to the hat, or I/O expansion board as it's called here. And that goes together like that. That was fairly straightforward. Fortunately, there was just one 4-way cable. It's not color coded, but of course it's written ultrasonic sensor there. Servo, again, listed in the manual very clearly about where the signal, the 5-volt and ground wire is, and also written there, so that's good. Next, we're going to basically connect the two halves together, like so. So essentially we have some riser bars that we're going to stick below and then stick the top on. This part feels eerily familiar for me. It's a bit like putting a quad frame together. Now, before we actually go ahead and shove this on and tighten up, the next bunch of pages on the manual, although it's pictured with the top on, nothing gets done up yet until we get these cables in. So we've obviously connected everything before we finally go ahead and put the top on. So we got these cables here. They all look fairly unique. It should be fairly easy. So I'm going to connect those now. And then we can get the top on, and there we go, we're all together. So a couple of fiddly sections in there perhaps for kids, mainly because of course this isn't connected and you have to manhandle this around to get the wires through. The biggest one being the line sensor that goes up through that one and up through that one and out through here. The wires are sort of plastic coated, so they're quite stiff. I mean, silicon coated wires would have been a bit nicer to move around, although I kind of like the fact that it looks a bit mad and crazy inventor type thing. As you can see, all we've got left to do really is put the wheels on, I think. Let's check the manual. It certainly looks that way. Get the wheels on and then we're on to testing it out and seeing what happens. So that's going to be fun. But let's get the wheels on first. Make sure that all goes together properly. Okay, here we are. Here's the finished product. No word of warning, there seemed to be a little element of self-tapping those screws there, and the pressure to get them on means these all need a little bit of tightening again, but that's just worth doing, going around tightening everything up. But yeah, pretty impressed with how easily this went together. In terms of, like, you know, I'm obviously a grown-up that's had a lot of experience in building stuff, so it went together fairly quickly. But even, you know, a keen teenager would put this together in no time at all, a couple of hours tops. Even a younger child, it's something you could go and build with them. Now, as far as the next steps, the manual here said, we've already uploaded the program, so you can skip this step, but there's all the codes you can modify and upload it to the car here. It also mentions about if you upload it, you have to remove the Bluetooth module. Maybe explains why it's in such a precarious position that we can unplug it, because it shares the same serial port as what would be the USB connection. But it's got some modes ready, so we'll go through this in a second. And it's got an app and stuff, so we'll do this. But just for now, has this got any juice in it? Let's have a look. Well, a light comes on. This already had a battery in it, so if we press forwards, it goes away. Backwards, there it is. Let's see if it turns around. Ooh, that looks fun. So this has got a bit of juice in it already, which is cool. I'm going to charge it up properly, and then we'll go through the modes it's got, and then we can look into what we can actually do in terms of expansion. So yeah, join me in a second. So I'm just charging up here. You see I've got the cable just plugged into a power bank. Light goes green when it's charging, light goes off, means it's fully charged. Well, welcome to the kitchen, where I've got a little bit more space, and plus I can sort of show you what's happening here, and we can see it's just a single press forwards, single press back on this little remote. When it tends to turn a 180, which is pretty bad if you want to go at a sort of right angle. But anyway, let's try the first thing is obstacle avoidance using those little sonic, ultrasonic sensors there. So if we press number 2, see what it does. It's off. It's gone a bit further than I expected. I didn't want you to go over there, I can't see you. Hang on, let's rearrange you slightly. Come here. That's better. You can see when it gets to an obstacle, it looks with its sensors using the servo to sort of get the gist of where the obstacle is. And then it turns around. It has collided a few times, and occasionally, yeah, it gets in this little sort of loop when it's like, oh no, there's an obstacle there and there's an obstacle there, I don't know what to do. I think this is possibly in the code where it's sort of saying it's all too close. So if we just move them a bit, and occasionally, as you see there, it's like, I've hit it. If you sort of don't get it straight on, then it tends to do a bit of a clonk. It will obviously be better if it said, actually, I'll just turn a little bit away and not do a 180. But yeah, we get the general idea. But because it does this 180, it seems that most of the time it sort of spends going back and forth on the same path. But it generally works. And it's managed to get out of its little trap now. So let's bring it out of this. Bring it towards me. And let's try line drawing mode. So to do this, I'm going to have to, I'm not sure it's going to work on this or not. I'm going to put a bit of tape on the floor, see if I can get it to follow it. Okay, so using the included PVC tape, I have drawn, well, it's not an oval, is it? But it's you know, kind of not bad. I guess it's going to work better the smoother the edges, but let's give it a go anyway. So what we've actually got 3 sensors here. So the idea is, I think, that it knows where its sort of middle and end positions are. So it kind of knows, I think, if it's going off the edge and how to do it. So what we want to do on the little remote here is just press 1 and hope for the best. And it's going. Oh, lost the line there. Oh, hang on. Let's try it again. So you see it doesn't really like sharp corners, and I think that's because it goes pretty quick and I think it overshoots. So what I've done here, I've sort of stretched the tape around in more of an oval, and it seems to like that a lot better. So just a tip there if you're getting this sort of thing. Hard corners it doesn't like, but of course the idea of this sort of thing is if you want to do hard corners, then you've got the opportunity and ability to change the programming and make it do it for you. So let's see if we can stop this now. So that is using the infrared remote control. There's a secondary option for control, and that is using the app on the phone. Fortunately, I already have this downloaded and it's available on the App Store on iOS, and I don't know if it's a direct download for Android. I noticed it in the download stuff. And yeah, it's quite a neat little application actually. So we've got this one, the Smart Robot Car, and what you have to do, is it connected or not? I don't know yet. Connect your device now, there we go. So let's go connect that. We need to be quite close to the Bluetooth. Yep, that's doing it. So what you've got here is basically a much finer control actually. So you can turn a lot slower, you can sort of move and actually sort of, you know, properly corner as you go. And you can still do things like, let's put it into obstacle avoidance. Like so, and it'll do its little thing. Behind you, turn around. Oh, I think it's caught in a trap again. What are you doing? There you go. Stop that. Bring it around again. And we should be able to... I'm trying to do this with my left hand, which isn't easy. If we get it towards the line, I should be able to go into line mode here. That work? Hang on. No, we're not quite lined up. Let's try again. Try that. There we go. And it's off again. So again, that's quite nifty, and I particularly like the much better control you've got. It's still, it could be a little bit better. It's still, if you touch it over, it's like, oh, you want to go all the way around. So you could have that a little bit smoother, I think. Anyway, if we come out of that, we've then got this thing called program. If your kids have used Scratch, then it's a bit like that. So you've got little things like, move forward. So we can change things about, like we don't like it going that fast. So we can say move forward 100, and then we could say, then I want you to move left. And, there's a little bit of variables, and there's loops to do the control. There's nothing in there. So if I just, in my program now, that is it. Let's click on go, and it should move forward a bit and then turn around. Oh, it's doing both at once. That's interesting. Let's press stop. Now, I did find out a bit of a problem because I thought, I'll quickly rewrite the sensing thing so the ultrasonic sensor didn't go wrong. And here's was my little test code. And all it does is basically say, other obstacles ahead, then turn around, or move forwards. And I thought I'd just be able to sort of gently go. But if I try that one, so what it does, it always seems to say there's always something in the way. And I guess there is always something in the way, but it might not be that close. So then I looked at their example program called obstacle avoidance, where you see they get a value of the ultrasonic sensor and then decide which way to turn based on what's in there. I thought, that's interesting. Let's try that one. And essentially, it kind of looks around, but never actually gets anywhere. It seems to suggest that it always finds things in the way and it can't seem to figure out where to go. So yeah, this is a little bit limited in what you can do. I mean, one of the things I want to do is like say, hey, what is the value of the ultrasonic sensor? But oops, I've just broken it. But you can't print things out here. So it's there. It's just a little bit limited. There's bits in there. You can pick randoms. You can make variables. But yeah, there's not quite enough there. And then we had this thing called DIY control, which I haven't even looked at what this does yet. What's it do? Okay, we've read the manual. It talks about sending commands, basically. So if I called this, for example, avoid, and I wanted to put it into avoidance mode, basically in the code, it sends the message 1, and I could make a color for it, and that would be that. So if I said, well, it doesn't actually seem to work. Now, is this because we need the latest control? It does say here, if DIY function doesn't work, please download the latest program from Elegoo. But this seems to be only able to add, different buttons to what you'd already have. Unless you expanded the control massively, you wouldn't have many. I don't know if I get this page, but I think it's the least important or the least interesting of all the pages there. The fact you can move our little guy around using either the remote or this, or put it into different modes, I think is quite cool. But anyway, that's the basic operations of how this thing works, and it seems to work pretty well. It's a little bit squiffy when it's going places, but this control is much better than using the infrared one because you've got a much finer amount of control. But what can we do with it? Let's say you're a teenager and you've put this together and you've played with it, and now, can you do anything else? Can we expand its functionality? So what I want to turn to next is what this thing said about what's on the website and what we can do with it. So let's take a look. Okay, so let's see what else we can do with the kit. I followed the link through in the menu to the elegoo.com download, and there's a bunch of stuff here. There's where to get the Arduino IDE from, although I do note that is slightly behind. If I just hover on that, it says this is 1.8.12, and if I go to arduino.cc, that's at 1.8.13. So I'd maybe pick up my Arduino stuff from the official Arduino site, but nice they've got it there. And you see what they've got is then download links for all their different things here. This is the BLE tool for Android. I'm guessing perhaps they haven't bothered putting that on the Google Play Store because you can obviously sideload an Android app, whereas on iOS, unless you've rooted your iPhone, you can't, and thus you have to go for the App Store. Anyway, this is what you download. You just click on this and you get a bunch of files. I have already done this, and this is what you get in that zip file. You get, I wonder what this was because it didn't come out right, and it's basically the instructions but in Chinese, so not very relevant for myself. This is very interesting and very welcome. In fact, they've got data sheets on each part of the build. You've got some of which are in a nice big detail. Here's the thing about the Bluetooth adapter there, and you can see exactly how it all connects. And on other things, like if we look at the ultrasonic sensor, again, it tells us about the sort of the range and angle it's got, what it sort of looks like, and we've even got example code about how it works with the Arduino. So this is some really good stuff. I mean, on here, not everything has quite that level of detail. If I look at the infrared remote controller, it's literally just that, but we can sort of delve into some of that. So this is really welcome, because of course, if you're going to do stuff with these different things, and you might want to program them differently, you might want to use them in completely different projects. So the more detail you can have on these is very welcome. Obviously, there's some things in other languages. There's the BLE tool again. So you've got the APK files for 32-bit, 64-bit Android. Not really interested in those. And then we go down to English. And what we've got here, very welcome again, is not just the fact that they've given us the main program. I mean, here's the actual program here. So this is the code that's actually running on the car that we can have a look at. But what they've also done is they've given these little lessons. They've talked about how to set up your development environment. So this is about how to install the Arduino IDE, and they talk about how to upload a sketch, which is what you call a program in Arduino, to your board. Which is really actually good. I mean, don't get me wrong, this isn't like your very first programming book. You couldn't quite go from absolute knowing nothing to using this, but they've really done a little bit of hand holding here. So just as an example, and this is why I think this is good, if I look at the main project for the car, it looks like this. We've got a good, I'd say there's a good few thousand lines of codes in here. There's some library includes, there's some horrendous stuff. If you look at the timer and how interrupt timers are set up, it is gobbledygook. But that's not where you want to start, because if you've never come to this sort of program before, that's really overwhelming. So if I look at the stuff they've got for, hey, lesson 1, let's make the car move, they've got here this one called Auto Go, which they talked about. And what they've got in here is something very simple that shows you how forward, back, left and right works. And aside from the code, they've actually got like PDF files about how to make the car go, and they sort of break it down, and they talk about the motor driver. I'm really quite impressed with this. I didn't expect this level of helpfulness from the guys at Elegoo, and it's here. So we've got things on speed control. Let's have a quick look. Right, stretch out, like right wheel rotation. Nice, really simple things about how it works and very easy to experiment with and get going. And they've got similar things on using the Bluetooth, using the infrared, obstacle avoidance, line tracking. And they've even got the stuff here about the rocker control, which is the stuff that comes in when you're connecting from Bluetooth from the phone. So it's all really, really good. There's a little troubleshooting guide, there's another user manual, and as I said, you've got the main code itself that you can mess around with. So what I thought I'd try and do is perhaps just expand this in a couple of ways, just quickly, because I know this video is already really long. So what I notice in here, and I don't have any real experience with infrared remotes here, but one thing I thought it did in the remote is when you turned, it was like a really big turn. So I wonder, could I include extra little things on the remote, say, because numbers 1 and 2 are used, but numbers 4, 5 and 6 could be used to set the different speeds, is what I was sort of thinking. And I can see here that you get like little codes that get read, and we haven't got one for the numbers 3, 4 and 5, or 4, 5 and 6 in fact. So I could check out how to do that and maybe try and update this a bit. So I'm going to mess around with that, and I'll give you a little progress report and see how we go. Okay, first off, please excuse the horrendous state of my desk, which, to be fair, always looks like this. So I've taken out the Bluetooth adapter for now, and I've plugged in the USB. That's connected to a little hub there. I've got the Arduino IDE up here. What I've done is I found the IR receiving part here, and because we don't know the codes of some of them, all I've done is just put little prints in to tell me the results when I basically press a button. So what I'm going to do, I've basically checked it verifies and builds. So if I just do a quick upload there, that said it's done uploading. And then what I've done is you can basically open a serial monitor, which I've done here. And I've opened that at 9600 board, because if you look through the code, that's what it's done. Now if I grab this and if I press like forward, just point at that, I get a little code come up, 167395. If you look up there, forward is 167395. So that's good. So if I now press number 4, I get a new code. Number 5, another code. Oh, hello. 2 codes there. I have to say, you don't always get the code you're expecting, but I think I've got enough times to get through. I think it depends on the timer stuff. But I've managed to get what I think a number 4, 5 and 6 is, so I can now do something with these inputs and see what we can get. There's interesting stuff here, like if you press say 1, but if you hold 1 down, you get this repeating code come out. Don't know what that's about. I think it knows if you've let go as well. But anyway, I've got some codes now, so I can try doing some stuff and trying to make this into a different control scheme. What I did here, I've kept my original one. I've just called this curry car, because of course if you cock this up, you can always then go back to your original. So this is just a straight copy, and I can do my changes in here. I can play around with it, and if I want to, I can always go back to the original. Okay, so here's what I did. That was a fun little experiment. It only took about 5-10 minutes of changing around, but quite interesting. So I got all the other key values, and then what I did is I decided I wanted to use car speed, but car speed was what's called a constant, so it was a defined, so I just changed that to an integer value that I could change around. And then we went down to where we had the IR get data, and what I did is actually something a little bit different than what I intended to do first off, because when I looked at the case for Bluetooth, it had these things called left forward and left back, and that runs a different thing, and I thought actually going forward and left and forward and right could be quite cool. So what I did then, I used let's have a look, where are we? Key 4 would be left forward, key 5 would set the car speed to 250, which is its default, key 6 is right forward, key 7 is left back, key 8 sets the speed to 200, key 9 is right back, and key 0 sets the car speed to 150. That will kind of make sense once I show you it in the context of the control. And that's about all I did actually. So let's, I've just uploaded that, so let's go test it out and see what happens. So here we are back in the kitchen, and what I'm talking about making sense is if you look at it here, that's left forward, left back, right forward, right back, and then we've got slow, medium, high. So at the moment it's default. Nothing should change if I just do that. That's the same. So if I press, well, let's first off do a a go forward and left. So you see it sort of turns a bit as it goes, and then we can go backwards and right. And then forward and left a bit more. And then what I can do is say, actually it's a bit far away now, isn't it? Then if I say, let's bring the speed down to slow, so if I press 0 and then try going forward, it doesn't go as far, and when I do a turn, it just turns about 90 degrees. And then we've got a medium value, which is 8, and 8, yep. And then it turns a bit more, and it goes forward a bit more. And obviously I got to slow it down as well. The little forward and right and back and left or whatever, they go a little bit less. But basically I can get a little bit more precise now. I'm not sort of caught in having to always turn 180. I can just sort of turn a bit until I want to stop. If I just want to turn a little tiny bit, I can do so. But that's just a little bit of example code, very easy to change. I just wanted to show, even if the whole thing looked complicated, doing little individual bits like this didn't have to be so.
Well, there you go. Wasn't that fun? I have to say I enjoyed that an awful lot more than I thought I would. And I was really impressed with the level of documentation Elegoo had put together. Well, I see a lot of these things, it's just literally a kit and there's no backup documentation or anything like that. If you did get stuck putting it together, there is actually a video that they made which has a nice top-down camera so you can see everything put together. There's a slight weirdness with it in which they build everything in completely the wrong order that's in the manual, but if you sort of got stuck at one bit, you could easily find the bit you're stuck at and take another look at that video and get it sorted out pretty easily. But this thing goes together pretty easily. It's very straightforward in terms of the build. Even if you make a couple of mistakes in sort of ordering stuff or rotating stuff, you'll learn pretty quickly that you've done it wrong and be able to correct it. So I guess the question is, how's it stack up as a sort of learning tool? What sort of level do you need to be at to get going on this one? And as I said before, it's not quite at the very I've never done any sort of programming ever before, I just want to jump in and do this. I think it really helps if you've had the basic sort of schooling level, you understand the sort of logic of it. So if you've played about in a bit of Python or even shell scripting and stuff like that, you'll be able to jump straight into the Arduino stuff and start messing about with it. And you know, you're not limited to messing with what's on here. This is a straight Arduino board. You can take that off and you can go through the very general sort of Arduino sketch tutorials. The first is just making a light blink and stuff like that. And you know, if you wanted to, you could rip that off the board and use it for other stuff. On my last project, which looks even more mad professor than that, this is the same sort of Arduino Uno board connected up to a standard IDE disk drive in order to read floppy drives formatted on an Amiga, and that worked quite well. It's not my project, by the way, I got it from somebody else, but the code all runs on the same sort of board. So the good thing about Arduino stuff, it's very, very widely used. So if you're stuck or you want to learn more, there's loads of tutorials on the official Arduino site. There's loads of people making YouTube videos about it, publishing code about how it works. There's loads of open source stuff on GitHub as well, so there's loads you can do with that. And you've still got all the pins accessible here, so if you wanted to expand this with extra sensors and stuff like that, you could do so. If you wanted to take these all off and do other things with it, hence you've got those datasheet things, you can do so. So you can do a lot with it, and it's a great starting point to get involved in this sort of programming. And I think it's great fun because there's programming just in code, and then there's programming things and interacting with physical objects, which is good fun as well, because you get to see your results a bit quicker, and you can see when it really goes wrong as well, because it starts bumping into walls and falling upside down and setting on fire and stuff. But yeah, I have to say, if you're interested in getting into this sort of program, this is very good. If you've got a child who you think might benefit from this sort of activity, then this is a good starting point. Yeah, I really like it. Highly recommended if you're in the market for this sort of thing. Got to say thanks to Elegoo for sorting this kit out and sending it over to me. They do a whole lot of kits and Arduino stuff
on their site, and of course I'll have links down below for where you can check that out in more detail. I hope you enjoyed this review. A little bit different, it doesn't fly or anything, but it was certainly fun for me checking out something like this. I hope you enjoyed it too. If you did, don't forget to give it a thumbs up and stuff like that. Anyway, hope that's been helpful, and I will catch you next video. Bye for now.
Well, you've made it to the end of the video, so thanks once again for watching. If you like what you saw, then please consider subscribing, and if you really like what you saw, then be sure to check out the link to my blog for a variety of ways in which you can help support this channel.